Hi, how you guys doing? So my name's Will Pepe. I got a PhD at RPI this past summer, and now I've got a startup which is kind of commercializing some of that PhD research. So I'll talk a little bit about the ideas behind the company and the technology, what are the problems we're trying to solve, and then I'll talk about the device and the business. I'll start off by pointing out this kind of obvious thing that a lot of people don't often think about, that plants make fresh air. Like, there was no oxygen on Earth before plants arrived. And so we're relying on plants like every second of every day in order to breathe, to make ATP in your cells and move your muscles and do pretty much everything that you do. You need plant-generated oxygen all the time. When we design our ventilation systems and our buildings and the things that actually supply our air, we're separated from plants. And so the thermal envelope creates a boundary between us and the plants. And so over time, people have basically designed workarounds. You take air from outside and you bring it in. And typically what you're doing is heating and cooling that air first. And so you've got this trade-off kind of between air quality or energy efficiency. If you want fresh air, you have to literally dump the air out the window, dump the heat out the window. So that's still the case in modern high-performance buildings. And in all these cases, we're kind of making this implicit assumption, like air is somehow fresh outside, it's being made somehow vaguely by plants. And so I'm kind of interested in returning to the original ecology, bringing those plants back inside, creating healthier and more efficient buildings. And so a conventional building, by analogy, is really kind of like an individual organism. It breathes in and it breathes out. And for people and for animals, this is like a really efficient way of venting heat. For buildings, it's also a really efficient way of losing energy. And so the idea with BIOM, with my technology, is to basically make the building more like an ecosystem. Equip it with a more complete set of biological components. And so this way, you're going to get, ideally, less energy and mass transfer across the envelope of the building, and that's going to make things healthier and more efficient. So what are the actual explicit problems I'm trying to solve? Like, why do we have to radically redesign our ventilation systems? Well, basically, building energy on the one hand is like a major driver of climate change. It accounts for almost half of all US emissions. And on the other hand, air quality, poor air quality is accounting for about 1 in 20 deaths in the US, where air quality is actually relatively good. And so these problems kind of intersect, where outdoor air ventilation is heated and cooled and then supplied in order to meet adequate indoor air quality. And this sort of extends mechanical solutions for dealing with these problems. The fact that they're still problems means that they're probably not great. I can talk more about that later afterwards if you want. And so the solution is to basically use moss, which is a green plant, to generate up to 100% of a building's fresh air requirements from inside. And so that means capturing toxic gases, toxic solids, and also the CO2 that we're breathing out all the time. And so moss is basically built like a filter. It's extremely porous. It has the highest surface area and porosity of almost any natural material on Earth. And so that surface area is supporting hundreds of thousands, if not millions of microbes that are capable of evolving to and degrading all sorts of different contaminants, including toxic gases like VOCs. At the same time, the moss itself can do photosynthesis. It can make oxygen for you. And then it also can do the same sort of thing that a HEPA filter does. It captures solids. In the case of the moss, though, it actually uses those solids as nutrients. And so it can live off of the pollution. This is what the technology actually looks like instantiated in a device. It's essentially like an air purifier. You can see one back there. At the moment, this is basically a really nice air purifier. It's, in my opinion, the best air purifier you can get right now. Going forward, what I'm interested in doing is sort of networking these things around the building to sort of go back to that idea of making the building like an ecosystem. And so you can start doing really interesting things, sensing and actuating the air quality in the building. So like you can take, for example, clean air where the devices are and move them into an occupied space where the devices are not. In a situation where maybe you have a huge amount of people, like a client meeting in a conference room, you could detect if you actually do need some supplemental outdoor air ventilation. Or if there's like a wildfire or an air quality crisis, you can go into sort of full recirculation mode. And this is really, in a situation like that, the only way that you can breathe clean air. And so I've done a lot of scientific research on this to see if this actually works the way that I think it does. I can talk all about this later if you'd like. We don't have time to go into the details now, but Basically, moss is a very good filter. We know that for sure. It's really good at doing photosynthesis a lot more quickly than we'd thought. We've characterized the highest rates of moss photosynthesis ever. And then at the same time, it can do all of that in a really compact package that is also very energy efficient compared to a regular plant. So can it make money? Here's the sort of question I'm asking myself now, like every day. And basically, at the moment, I'm focusing on commercial clients, so offices, hotels, schools, things like that. And the business model is you could buy one, and then you could, if you would like to as well, subscribe to a maintenance, really modest, maintenance contract where we'll basically make sure that the moss is doing well, and we'll refill the water tank once a month. Or you could just lease the device, and we'll cover everything, the device and service all in that lease. So currently, I've basically spent, the last 3 or 4 months after my PhD building the first prototypes, figuring out how to really get it working well in terms of a device. Then in the last month or so, I've started selling a few of them. So they actually are in a few early adopter spaces right now. People do seem to like them. And so what are the next steps? We want to continue building these things and putting them into spaces. That's like the primary goal of the company. But at the same time, what we really are interested in doing is a large pilot project. So we want to take a bunch of these things, network them, connect them to a building's HVAC system, and see if what I'm talking about is actually going to make a building healthier and more efficient on a big scale. And so if there's anyone out there that has a commercial space that they'd like to do this in, please let me know, because we're really looking for people who are interested in doing basically a really cool experiment that might make your building more efficient and might make your occupants healthier. And then at the same time, we're looking to raise funds, whether that's through grants or through some investment, to basically hire a real industrial designer, and not me, who has a degree in math and not anything related to design necessarily. We want to scale up the manufacturing, make it more efficient and cheaper. And we want to also build out our maintenance infrastructure. So moss is super low maintenance compared to like a green wall, but there's still some stuff that needs to be done on approximately a monthly basis. You come in, kind of check the device, make sure everything's okay. And so as we start selling more units, we need to have a maintenance infrastructure as well. Here's a competitive landscape. We can talk also about this again afterwards. But basically, the device is situated somewhere in my mind between an air purifier and a green wall. And then finally, here's the team. I'm the only full-time member at this moment, but a lot of interesting people have helped me develop this technology and device over the years. And I've also got some really great institutional partners, including RPI and a few architecture and engineering firms in New York City, where the company is based right now. So yeah, that's it. Happy to answer any questions you may have. Thank you.
So I was wondering, can you tell us what some of the key metrics or KPIs associated with this product is? And actually, a second question as well, how do you envision monetizing this? Is it through the sale of the product, or is it LTSAs, long-term service agreements, or something like that?
Yeah, so I think so to answer the last question first, in terms of monetization, I think, well, right now it's about 50-50 in on terms of an annual basis. But obviously, if people like the devices and they stay in places long term, the revenue will shift more towards the service side of things, the subscription. And then in terms of the metrics, we're looking at air quality metrics on the one hand. So how much contaminants are in a volume of space, basically like a concentration. We want to compare that to things like a HEPA filter, other things like that. So we've done a lot of that. Our device is better than the state-of-the-art technology. And then there's also the energy efficiency stuff, which is why we want to do a pilot project. And then the sort of third metric we're looking at is actually physiological characteristics. So that's again with the pilot project. We want to give people, for example, like a cognitive function test in a room with the device versus a regular room that's got a mechanical HVAC. So we want to see if people are actually performing better physiologically or cognitively with the device in the room. So yeah, there's air quality, physiology, and then the energy efficiency as well.
So great presentation, really fascinating. Probably oversimplify the question here, but to some degree it sounds like the end goal is replacing oxygen generation and effectively sealing a building versus what mechanical ventilation or energy recovery ventilation does, which is ideally it's getting stale air out of the building and it's bringing fresh air in from the environment, right? So to completely replace that system and effectively seal the building, which is really ideal, I would say, if it could be achieved, how many of those do you need to actually reliably support life in that building that no longer can get oxygen from the outside environment?
Yeah, so if you want to fully seal your building off, which is kind of the direction in terms of energy efficiency standards that the building industry is going in, you need about one of those per person to do 24/7 continuous oxygen generation for a person, or really what you look at is the CO2 per day. So we breathe out about a kilogram of CO2 per day. It can capture that much CO2 every day. So one per person in that regard. And if you do that, you'll be really oversized for air filtration. So you'll have very good air in that case.
Great presentation, really loved it. I was kind of curious as to, are there any environmental constraints on this device? Like, I know we're not as cold as Alaska, but could these be in Alaska or the Caribbean? Are there any kind of environmental constraints to using the device, or is it kind of self-contained where that doesn't really matter?
It's totally self-contained. The species of moss we're using also exists on all 7 continents, so it's likely to be okay kind of anywhere that you put it. So yeah, it could pretty much go anywhere. But also to kind of, we mentioned like Alaska, as you go to more extreme climates, you can save more energy by recirculating air. So it'll actually do better in more extreme climates from an energy efficiency perspective.